Today's problem is gas station. This is on interview bit. Actually, this is a very popular question. You can find this anywhere, but I mean, in this case, we're doing it on interview bit. So you can pause the video at this point, go over to interview bit, try it out, come back, and we'll look at the solution. All right, difficulty medium. Yeah, you can see this is this question has been around based on the number of likes, 651. Asked at Google, Amazon. That F kind of looks like Facebook. That's actually Flipkart, which is just online shopping in India, and Microsoft. Problem description. Given two integer arrays, actually we have lists in the Java template. There are size n. Actually, you can't really see that. Maybe I could just squeeze it over for a second. This is what the method signature looks like. Can complete circuit, and we have a list A and we have a list B. All right. Let's see. A and B, size n, there are n gas stations along a circular route where the amount of gas at station I is A at I. Just parenthetically, I'm not crazy about the interview bit policy of calling all the input variables A and B. You know, if you would, you know, call it like gas, you know, and the costs are in B, so why not call it costs? But anyway, it's A and B. Let's see. Okay, amount of gas is A at I. You have a car with an unlimited gas tank, and it costs B of I gas to travel from station I to station I plus 1. You begin the journey with, I guess, you know, I plus 1 mod n, since it's circular. You begin the journey with an empty tank at one of the gas stations. Return the minimum starting gas station's index if you can travel around the circuit once. Otherwise, return -1. You only travel in one direction. I, 2, I plus 1, I plus 2, etc. N minus 1, and then 0, 1, 2, etc. So completing the circuit means that you start at I and you finish at I. Now, it is possible that there could be more than one solution, so that has to be understood before you jump into this. In this case, they say return the minimum starting gas station. Now, I've seen, I think, like lead code says guaranteed that there will only be one solution. So then it's on them to just, you know, give you something with only one solution. I think that's a common practice on lead code. They'll, you know, occasionally guarantee you that there will be a unique solution. All right, in this case, return the minimum starting gas station's index. Problem constraints. Length of A between 1 and 5 times 10 to the 5th, wait a minute, 10 to the 5th, no, 500,000. 500,000. Okay, so definitely we need a linear algorithm here. Size of A equals the size of B. A, which is amount of gas at the station, will be between 0 and 5,000. B, which is the cost of gas to get to the next station, will be between 0 and 5,000. Input format, we have A and B. A A is the gas array, B is the cost array. All right, return the minimum starting gas stations index if you can travel around the circuit once. Otherwise, return -1. Okay, yeah. I mean, it's possible that the distance that you need to travel to get all the way around is more than the amount of gas available at the stations. So in that case, we would return -1. Otherwise, and we'll do a walkthrough with a better example than this, but let's use the example that they have, which is we'll try starting at station 0, since that's the minimum station. We can get a gallon of gas at station 0, but it takes 2 gallons of gas to get to the next station. So that said, we can't start at station 0. Well, what if we start at station 1? Now, there we can get 2 gallons of gas. It only takes 1 gallon to get to the next station, so we have 1 gallon left. When we get there, we get 1 gallon. Now we have 2 gallons. It takes 2 gallons to get to the next station. So we're good. We can start at 1, and we can get all the way around. All right, we can solve this with a greedy algorithm, meaning we're just going to try each station. Okay, we'll start at 0, and we'll just take all the gas available at every station. And we need to keep track of 2 things. All right, we have this one variable here, current gaining. That means, do we have enough gas to get to the next station? And if we don't, then whatever we picked as a starting station is not going to work. And then we'll go to the next candidate station. Total gaining. Total gaining is, do we have enough gas to get all the way around? So that's a running total. Current gaining, we do not want that to go negative, meaning, you know, we're somewhere where there's not enough gas for the distance to the next station. Now, the total gaining can go negative, but by the time we get to the starting station again, if we get to the starting station again, total gaining would have to be non-negative. If it's negative, it means that the total distance is greater than the total gas available. Okay, I'm going to write up a different example here to work with, and then we can go through it. All right, we're going to use these numbers for A and B. So we've got current gaining initialized at 0, total gaining initialized to 0. Candidate station, our first candidate is station 0. We've got a loop here that is going to take us all the way around the circles from, it's going to take us all the way around the circle. Let's see. So let's start here, and A, current gaining, we started station 0 here. Maybe I should write those. 0, here's our index, 0, 1, 2, 3, 4. Starting at station 0, we take all the gas. We got 1 gallon of gas, but it's it takes 3 gallons to get to the next station. That's bad. All right, so current gaining is A minus B. 1 minus 3 is -2. Total gaining, same. It is -2. If current gaining is less than 0, it means we can't get to the next station. So candidate equals I plus 1. Candidate is now going to go to 1. All right, and current gaining, we're going to reset to 0 because we can't start here. So get that. All right, I'm just going to get rid of it for now. Next time through the loop, I will go to 1. At station 1, we can grab 2 gallons of gas, but it takes 4 gallons to get to the next station. So that's a loser. So this is, again, -2. Total gaining is going to be -2 minus 2. So let's see. Let's erase that. And no, I didn't do that. And that is now at -4. What next? Current gaining. Is it less than 0? Yes. Yes, it is. So candidate goes to I plus 1. That is 2. Current gaining goes back to 0. Rather than write 0 right now, I'm just going to erase that. Okay, next time through the loop. I is now 2. Station 2. If we go to station 2 and we grab all the gas, we got 3 gallons of gas, we need 5 to get to the next station. All right, so 3 minus 5 is -2. Okay, that's not good. And then total gaining, again, we have to subtract 2. Keeping in mind that it doesn't matter if total gaining goes negative as long as it is not negative by the time we finish this loop. Right, so now we are at -6. Current gaining less than 0, yes. Candidate. All right, 2 didn't work, so let's try 3 as a candidate. Okay, and we set current gaining back to 0. That's gone. All right, we are going through the loop again. I is 3. If we go to station 3 and we grab all the gas, 4 gallons, it only takes 1 to get to the next station. So current gaining from station 3 would be 3. All right, and if we add that to total gaining, which is currently -6, then it becomes -3. All right. Is current gaining less than 0? No. So we can keep 3 as a candidate. All right, next time through the loop, 4. 4. If we go to station 4 and we grab all the gas, there's 5 gallons of gas there, and it's only 2 to the next station. So again, current gaining is going to be 3. And we would add that to total gaining, which is currently -3, but -3 plus 3, we are at 0. Is current gaining less than 0? No. All right, and we're done because that's the size. We've gone through the size of the lists. So the winner here is 3. Well, let's take a quick look at how that works. If we start at station 3 and we grab all the gas, 4 gallons, and we use 1, by the time we get to station 4, we still have 3 gallons. So we grab all the gas again. Now we've got 8 gallons, and we need 2 gallons to get to station 0. So now we've got 6 gallons, right? We grab all of the gas here, and we have 7 gallons, and we need 3 gallons to get to the next station. When we get there, we've got 4 gallons left. 4 gallons. We grab 2 gallons. Now we've got 6 gallons. We need 4 gallons. So by the time we get to station 2, we have 2 gallons left. We grab all the gas. Now we've got 5 gallons. It takes 5 gallons to get back to where we started. And so if total gaining is greater than or equal to 0, which it is, return the candidate. If it isn't, there's not enough gas available to get all the way around. So -1. All right, let's try this. We can get rid of all of that and submit. All right, thanks for watching. If you found this helpful, hit like, subscribe, check out the playlist on screen to keep leveling up your interview skills. Most interview problems follow a pattern. This uses the greedy algorithm pattern, and I put together a free guide covering the patterns that show up most often in interviews, including greedy. And the link to that is in the video description. So you can download that immediately. It's free, and we'll see you next time.